Lesson 86, calculating the midpoint and length of a segment. First off, let's review using the Pythagorean theorem. Pythagorean theorem used when distances are difficult to measure directly. So you use the Pythagorean theorem when you have a right triangle. For this example here, we have a grid which is dealing with streets. And not always will your streets be in straight lines like you see here. And so to find the distance from one point to the other, you can't go through houses to find the distance from one point to another. So here you'd use the Pythagorean theorem to help you determine the distance from 2 points. So here it says the diagram shows a grid of city streets. A car travels from point P to point Q by moving east to point R and then south to point Q. What is the direct distance in city blocks from point P to point Q? So they want to know how many blocks is it from here down to here. So they're going to use the formula the distance for PQ, so from here to here, equals the distance from PR, here to here, to the distance RQ. And those are all squared. So let's do that first. From P to R, how many blocks is it from P to R? P to R, we got 1, 2, 3, 4 blocks. I'm going to put 4 squared here. And then the blocks from RQ, we got 1, 2, 3. So that's 3 squared. That's going to give us whatever PQ squared is going to be. And we can't just count here and say it is 4 because that's not exactly 4 blocks. So we're going to use the Pythagorean theorem to solve this. We have 4 squared, which is 16, plus 3 squared, which is 9. And that's going to give us whatever PQ squared is going to be. 15 plus 9 is 25 equals PQ squared. Now to undo a square, we find the square root of both sides. So PQ has to equal the square root of 25, which would be 5. So 5 blocks would be the distance, city blocks, for the distance from point P all the way down to point Q. And you'll notice if we just counted these blocks right here, the way that it's shown, you would have 4 instead of 5. So using the Pythagorean theorem here made it easier to find the distance between those 2 points. Next, here we have the same diagram here. We want to find out what is the distance, the direct distance in city blocks from the corner of C Street, and 5th Avenue, or in 2nd Avenue. So from here to the corner of D Street and 5th Avenue. So D Street and 5th Avenue. They wanted to find the distance from those 2 points. From here to here, what is that distance? And to do this, we're going to use the Pythagorean theorem again. We can go straight down here and then go straight across. So we form a right triangle. So here we know that this is 1 block, and we know we got 1, 2, 3 blocks here. So now we want to find out C squared. So C squared equals your A squared we're going to use as our yellow. So 1 squared plus our B squared, which would be a red. That's 3 squared. So 1 squared is 1. 3 squared is 9. That should give us C squared. C squared would equal 10. To undo the square, we find the square root of both sides. And we get C equaling the square root of 10. Now, since they're asking you to find out the distance in city blocks, it says use a calculator to approximate the answer to the nearest whole city block. we take our calculators and you find the square root of 10, you would get that to equaling 3.1622 and so on. So to the nearest block, we would say it was about 3 blocks. So just always be careful on what they are asking you to write your answer as. So here to the nearest whole block would be 3. Next, instead of using the Pythagorean theorem, they have another formula, the distance formula. And the distance formula can be used to find the distance between 2 points. And the distance formula is here. D for distance equals the square root of x2 minus x1 squared plus your y2 minus y1 squared. So let's find the distance between these 2 points. So again, this is my x1, y1, x2, y2. We'll substitute those numbers in for our formula. So I have 6 minus 3 squared plus 4 minus a negative 2 squared. 6 minus 3 squared is 9 plus 4 minus negative 2, which is 6. 6 squared is 36. If I add those two together, I get the square root of 45. Now we can simplify that in the simplest radical form. So I can divide this by the square root of 9 times the square root of 5. And this will give us an answer of 3 times the square root of 5. Next, find the distance between points 2, negative 2, and 4, negative 3. So our x1, y1, our x2, y2. Substitute them in our formula. So we got 4 minus 2, and we have negative 3 minus a negative 2. 4 minus 2 is 2, and 2 squared is 4. Negative 3 minus a negative 1 is a negative 1. Negative 1 squared is 1. So this will give us our distance. If we take 4 plus 1 gives us the square root of 5. So our answer here would be the square root of 5. Next one, substitute our numbers in. So we have 4 minus a negative 3 squared and 2 minus a negative 2 squared. 4 minus negative 3 is 7. 7 squared is 49. 2 minus a negative 2 is 4. 4 squared is 16. Now we have 49 plus 16 gives us the square root of 65. And I can break that apart as the square root of 5 times the square root of 13. But there is no partners in there, so I would keep my answer as the square root of 65. Next one, determine whether the quadrilateral ABCD is a rhombus. First, we need to remember what a rhombus is. A rhombus is just a quadrilateral with 4 congruent sides. That means the distance from each of the corners are all the same. So to do this, we need to find the distance from each point around the quadrilateral here. So let's find the distance from A to B. I'm just going to use the distance formula. So now I have 2 minus a negative 1 squared plus 1 minus 0 squared, which will give us 2 minus 1 minus a negative 1 is 3. 3 squared is 9. So this is 9 plus the 1 gives us the square root of 10. So this is AB. From BC, we have distance equals the square roots. So we're going to go from B to C now. B to C, we have 1 minus 2 squared, and then we have negative 2 minus 1 squared. 1 minus 2 is negative 1. 1 squared is 1. Negative 2 minus 1 is negative 3. Negative 3 squared is 9. That would give us the square root of 10 when we add them together. Next, we need to find from C to D. So C to D. We have negative 2 minus 1 squared and negative 3 minus a negative 2 squared. Negative 2 minus 1 is negative 3. Negative 3 squared is 9. Negative 3 minus a negative 2 is a negative 1. Negative 1 squared is 1. So that gives us the square root of 10. And then our last segment is from D to A. Plug those into our formula. So we have negative 1 minus a negative 2, and we have 0 minus a negative 3. Negative 1 minus a negative 2 is positive 1. 1 squared is 1. 0 minus a negative 3 is 3. 3 squared is 9. 1 plus 9 is 10. Square root of 10. Since all four sides all equal the square root of 10, yes, this is a rhombus because of all four sides are the same distance. Next one, determine if this one would be a rhombus. Now we'll do the same thing here, but we could actually look at the shape and we can determine that the distances aren't the same because over on this side right here, it looks like you have shorter distances. But we can't just go by looks. We need to prove that it's not a rhombus. So we're going to do the same thing, find the distance from P to Q. And in order to do that, we need our coordinates. So the coordinates here would be negative 4 and 0. For coordinate Q, we would have negative 1 and positive 3. R would be negative 3 or positive 3 and a negative 2. And S would be negative 1, negative 5. So let's find from P to Q. Find their distances. So from P to Q, we have negative 1 minus a negative 4. And then we have 3 minus 0. 1 minus negative 4 is 3. 3 squared is 9. 3 minus 0 is 3. 3 squared is 9. So this gives us the square root of 18. Find distance from Q to R. We have 3 minus a negative 1, and we have negative 2 minus 3. 3 minus a negative 1 is 4. 4 squared is 16. Negative 2 minus 3 is negative 5. Negative 5 squared is 25. So here, if I add those two together, 16 plus 25 gives us the square root of 41. So I can already stop right there and determine that they are not the same distances. So we would say no, This is not a rhombus. Next, working with midpoints. Midpoint of a segment just means the midpoint of M of the segment with endpoints x1, y1, and x2, y2. So it's the halfway point between a segment. And so when you're trying to find the midpoint, you're taking your two x coordinates divided by 2, find your two y coordinates divided by 2 to find the midway point. So here, I take my two x's, 3 plus 7, divide that by 2, that will give us our x term. And if I take my y's, 5 plus a negative 2 divided by 2 will give us our y terms. So 3 plus 7 is 10, divided by 2 gives me an x coordinate of 5. And 5 plus a negative 2 is 3. 3 divided by 2 is 3/2, or 1.5. So the midpoints would equal 5 and 3/2. Next one, find the midpoint with endpoints of 7, 10, and 5, negative 4. So we got 7 plus 5 divided by 2, and we have 10 plus a negative 4 divided by 2. 7 plus 5 is 12. 12 divided by 5 is 6. 12 divided by 2 is 6. 10 plus a negative 4 is 6. 6 divided by 2 is 3. So our midpoint would be 6, 3. Next one, find the distance between negative 2, 3, and 4, 7. This one should actually be the midpoint. Find the midpoint instead of the distance. So we'll have negative 2 plus 4 divided by 2, and we have 3 plus 7 divided by 2. So negative 2 plus 4 is 2. 2 divided by 2 is 1. 3 plus 7 is 10. 10 divided by 2 would be 5. So the midpoint would be 1, 5. And some application. Coordinate plane can be used to model positions of players on a football field. The quarterback is on the 30-yard line at 30-10. So that'll be here. He throws a pass to his receiver who is on the 50-yard line at 50-40. It would be here. Find the length of the pass as a radical in simplest form. Then use a calculator to estimate the length to the nearest yard. We need to find the distance from Q to R. So I use the distance formula. Take our two x's. The difference between the two x's is squared. Add that to the difference of our two y's and square it. So I have my x's. I have 50 minus 30. And I have my y's, which is 40 minus 10. 50 minus 20 is 20. So 20 squared plus 40 minus 10 is 30. 30 squared. So we got 400 plus 900. That would give us the square root of 1300. If I break that apart, this would be the square root of 100 times the square root of 13. Square root of 100 is 10 times the square root of 13. That would be the distance in simplest radical form. And to put that as a nearest yard, we would do 10 times the square root of 13 to give us 36.05, which to the nearest yard would be 36 yards. And our last one. Quarterback is on the 20-yard line at 20-33. He throws a pass to his receiver who is on the opponent's 58-yard line at 58-15. Find the length of the pass as radical in simplest form, then use a calculator to estimate the length to the nearest yard. I take my distance formula, plug our numbers in. So I have 58 minus 20, and I have 15 minus 33. So 58 minus 20 gives us 38. 15 minus 33 gives us a negative 18. We square both of them. So 38 squared is 1,444. Negative 18 squared gives us a positive 324. If I add my numbers, gives us the square root of 1,768. Then break that down. In simplest radical form. So we take the 1,768. See, divide that by, we divide that by 4, so the square root of 4. That gives us the square root of 442. I can divide that into square root of 2 times the square root of 221. Let's see if we can break down the square root of 221. And I don't have any numbers to break it down. This is as far as I can break it down. So my answer would be 2, because the square root of 4 is 2, times the square root of 442, because I cannot break that any further, which would give us a simplified answer of, so if I take the square root of 442, and times that by 2, that gives me 42.04. So to the nearest yard, it would be about 42 yards. That is our lesson today on calculating the midpoint and length of a segment.